All right, AP Stats. So, what we are going to do now, we are going to today look at sample proportions. Because we don't have this applet that it's talking about in these first few examples, unfortunately, we are not going to be able to cover any of this. So, in your notes or wherever you are, go ahead and cross that out. Now, where we're going to start is with some definitions. So, let's do this. Let's assume that we are going to choose an SRS of size n from a population of size capital N with some p number of successes. So we're going to get into some probability today. Then, a couple things about that. First, the mean of the sampling distribution of a sampler proportion is this. The mean of all of your p-hats, of all your proportions, is going to be the same as just your proportion for the entire population. Now, for standard deviation, this one is a little bit more involved, a little bit bigger formula. For the standard deviation of a sample proportion, you have to do the following calculation. You have to take the square root of p multiplied by 1 minus p, that quantity divided by n. That will tell you the standard deviation. Now, for the 10% condition, basically what that's saying is as long as this holds, as long as your sample size n is less than or equal to 1/10 the size of your total population n, then that will work. If this is not true, then you cannot calculate standard deviation. Now, kind of an alternative inequality to this, if you were to multiply each side of my inequality by 10, on the left side you would have 10n, on the right side you would have 1/10, and 10 would multiply to just get you 1, so you would just have n. So sometimes as an alternative, if we know the size of the sample, we can go ahead and calculate that just to double check to make sure that the population would be bigger than whatever that ends up being. So just kind of an alternative to the inequality over here. So last thing is the large counts condition. And what this is talking about, as n increases, the sampling distribution of p hat becomes approximately normal. In other words, for it to be a large enough sample size, a large enough n, it needs to satisfy both of these conditions, which we've seen before, that n times p must be greater than or equal to 10, and n multiplied by 1 minus p also needs to be greater than or equal to 10. So in other words, if your sample is large enough for those two conditions to hold, then you will have something that is approximately normal. Okay, so let's look at some examples here. For the first one, it says about 75% of young adult internet users ages 18 to 29 watch online videos. Suppose that a random sample survey contacts a simple random sample of 1,000 young adult internet users and calculates proportion p hat in the sample who watch online videos. First question, it says this: what is the mean of the sampling distribution of p hat? So we're looking for what is the mean of our sampling distribution of p hat. Well, keep in mind that that's just the same as what it would be for our proportion of the population, which it told us was 75%, so 0.75. All right, so for standard deviation of your sampling distribution of p hat, we are going to do this calculation. We would say the standard deviation of p hat is equal to, remember, the square root of p multiplied by 1 minus p over n. So what that would look like for this particular problem, we would say that p in this case was our 0.75, multiplied by 1 minus p, so 0.25 there, divided by our sample size n, which it said that we were taking 1,000 for our sample, and that should simplify to get you 0.0137. Now, the second part of this problem, I'm going to kind of draw a line here. It says check that the 10% condition is met. I'm going to use the following as my formula. I'm going to use the formula where we talk about 10 multiplied by n being less than or equal to capital N. So in this case, that would be 10 multiplied by 1,000 is less than or equal to capital N. 10 multiplied by 1,000 would be 10,000. And what we need to kind of think about is our population going to be greater than or equal to 10,000? In other words, are there more than 10,000 people who are age 18 to 29? And I hope you would agree that there are. There are a lot more than 10,000 people who are between the ages of 18 and 29, so it looks like our 10% condition is met. Okay, so in 3 here, as you see my girlfriend texting me, in 3 here, it says, is the sampling distribution of p hat approximately normal? Check that the large counts condition is met. So, is the sampling distribution of p approximately normal? The answer is yes. Now, the reason being we need to check for this large counts condition. In other words, we need to check to see is n multiplied by p greater than or equal to 10? And is n multiplied by 1 minus p also greater than or equal to 10? So the first one, n multiplied by p, you would take 1,000 multiplied by p is 0.75. We need to check to see is that greater than or equal to 10, which 1,000 multiplied by 0.75 ends up being 750, and 750 is definitely greater than or equal to 10. So similar over here, you're taking 1,000 multiplied by 1 minus p, so 1,000 multiplied by 0.25. Once again, checking to see if that is equal to 10. This time you get 250 is greater than or equal to 10, so it checks out for both. Okay, so then number 4. If the sample size were 9,000 instead of 1,000, how would this change the sampling distribution of p hat? So, a couple of things. The shape as well as the mean wouldn't change. Those would stay the same. The spread, or the standard deviation, would. The new standard deviation would be the square root of 0.75 multiplied by 0.25 divided by your new n, which would be now 9,000. So your new standard deviation would be 0.0046. So standard deviation would decrease in size, which should make sense. Remember, as the population size increases, standard deviation decreases. They are inversely related. Okay. So, last example here, and we will be done for today. It says, superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. Suppose that 80% of all middle schoolers in her district are planning to attend a four-year college or university. So, this 80%, there is your P. It says, what is the probability that a simple random sample of size 125, there is your n, will give a sample proportion of at most 75%. So what we're looking for here, we're looking for what is the probability that our sample proportion, p hat, is at most 75%. In other words, that it is less than 0.75. Now, keep in mind, it told us that our mean of p hat, the mean of our sampling distribution, is 0.80. Remember, that's just the same as p. Now, standard deviation, let's go ahead and calculate that here. That would be the square root of n, which is 0.8, multiplied by n minus, or p, which is 0.8, multiplied in parentheses 1 minus p, which would be 0.2, divided by our sample size, which is 125, would give us a standard deviation of 0.036. Now, here is kind of where I'm headed. I want to be able to calculate this probability. Now, it doesn't say anywhere that this was normally distributed, but if I can find the mean, which we did, and if I can find standard deviation, then assuming that this is a large enough sample, we can go ahead and use normal CDF eventually. So our end goal, here's what we want to be able to get to. We want to be able to use normal CDF to say pick something infinitely small, and then my upper bound being 0.75. My new mean we just calculated was 0.80, and standard deviation was 0.036. Okay, so that's kind of our goal. That is what we are working towards. Now, so far, the only thing standing in our way from being able to just type this in a calculator and call it good is that we need to decide whether or not this is approximately normal. So, first thing, we need to check to make sure our standard deviation calculations were allowed. In other words, this is where the 10% condition would apply. So, for 10% condition, what we would need to check is this. We need to check is 10 times n less than or equal to our sample size. So we would need to check 10 multiplied by our n value, which was 125. Is that reasonably less than our entire sample? In other words, is 1,250 going to be smaller than the total number of middle schoolers in this district, which, being a very large school district, it's fairly reasonable to assume that there would be more than 1,250 middle school students. I mean, if you think about it, just at Hawker Grove, in our school district, there's roughly between 200 and 300. So you multiply by 4 there, about 300 kids, multiply by 4 is about 1,200. It's reasonable to assume that 1,250 would be less than or equal to n for a very large district. Okay, so next thing we're going to check to see is the large counts condition. Now, the reason why we are checking large counts condition, we want to see if this would be considered approximately normal. Now, to check large counts, remember there are two ones that you have to check. Is n times p greater than or equal to 10, and is n times 1 minus p greater than or equal to 10. So, for n times p, that's 125 multiplied by 0.8. We are checking to see is that greater than or equal to 10, which it does. It ends up being greater than or equal to 10 there. Next, we would check the same thing over here, so 125 multiplied by 0.2, is that also greater than or equal to 10? Which it is. So we can say that this would be approximately normal. At which point, we are good to go ahead with this calculation. So put this in your calculator, normal CDF, pick something very, very small, like 0, 0.75, then 0.85, 0.036. That will end up giving you a probability of 0.0824. So what that would say, if you were to interpret it, is that about 8% of all SRSs, simple random samples, of size 125 will give a sample proportion. In other words, will give a p-hat of less than 75%. All right, guys. So, just as a reminder that for homework tonight, it is actually not out of the book. You will actually have a worksheet that you should be working on. That worksheet for you is, let me see what I've titled it for you guys. Should just be called Worksheet Sample Proportions. So, for block days class, so for either Wednesday or Thursday, you should be working through worksheet, if I can get the pen to work here, should be working through worksheet sample proportions. There will be an answer key posted for you. Remember, I am collecting both worksheet sample proportions and the sampling distributions day number 2 homework. Both of those will be collected on block day, whether that's Wednesday or Thursday for you. Also, please be sure you are getting with me to get your test retakes done. So if you are decided that you want to retake a test, please be sure you come in and see me about getting started on test corrections, seeing what you need for extra practice, and making sure you are ready to go by your test retake day. All right, guys, that is it. Have a great rest of your Tuesday, and I will see you on block day.